Hello. It's the end of the day. I hope you have some brain capacity left for PLC secure coding practices. Before we start, I would like for you to think for a moment, for you, what is a security decision? What do you think of when you think of a security decision? And while you think a bit about that, just for the sake of an example, we've got a network there, an OT network with see the Purdue model layers, blue on the bottom, the field level, up to green control system, and enterprise level in yellow. And of course, our protagonist for today, the PLC, programmable logic controllers in blue in the middle. And a few of the possible cybersecurity decisions that could be decisions I've marked red here. And when you look at that, there's two things I hope you realize. First, the things that you see there, the security decision is not one big thing. It's not one fancy element you put in your network, but is a hodgepodge of many smaller decisions that also, second, don't always look like security decisions, right? So they don't always have a security tag or anything on them. And it's, even if you don't think about security much, and most control system engineers don't think about security that much because it's simply not their day job, you're making security decisions all the time anyway, right? It's virtually impossible not to make a security decision. You're always making them. And same holds true for the entire network, but also for our protagonist for today, which is the PLCs. And top 20 PLC, secure PLC coding practices are exactly that. We're trying to make visible what kind of configurations or coding you do to PLCs that is also security relevant. So you're always making security decisions anyway. Our only job is to try and make them conscious decisions, right? So that's what the top 20 are about. And when CSA asked me to talk about the top 20 secure PLC coding practices today, I realized it's actually been almost exactly a year since we released the first version. So it's probably a good point in time to give an update on the project, but also to see what they are, clarify a few misunderstandings, what they are not, and also have a few details on how to implement them, what you should be doing about them. That's what we're going to do today. So the secure PLC coding practices, first of all, why has everyone been so excited about that one, about the project? First of all, PLCs probably are your most quintessential OT device. If you look at the picture here, you have the processor on the right, you've got some kind of IT network on the left, and the PLC are in between, right? So that's the elements that are real-time capable, that's the elements that are deterministic, that's the elements that operate in rough operating conditions, and almost every piece of OT has a programmable logic controller in there. So understandably, everyone who cares about OT security also cares about PLC security. And at the same time, we've known that PLCs are vulnerable for years, for decades, at least since 2012 Project Basecamp. We've been hearing that over and over. We've been reading those headlines over and over again. We know they are vulnerable. We've been knowing that all the time. And automation engineers have been yearning for something that helps them do something about that, right? So we've been repeating that over and over. They're vulnerable. We know they're vulnerable. And I always have in mind an old automation engineering professor of mine who said, you know, we really do want to do something about security. Whenever we talk about any fancy new technology in automation, someone in the corner stands up, some spoilsport, and says, have you thought about security yet? And you know what? We want to think about that, but we need people to tell us how to do that, to make all the invisible security decisions visible. And from IT, we know IT secure coding practices. So at some time at S4 in 2020, the idea came up to say, okay, let's try and do something similar for PLCs. And There was nothing like this before, and that's why people were so excited about the top 20. And when I say people that were excited, here are a few facts and stats about the project and the surrounding projects. First of all, it's important to note the top 20 were and are a community project. There's a bunch of volunteers thinking about their top tricks and tips they have when securing PLCs, when operating PLCs reliably, because remember, a security decision is not always only security. And I don't have any time machine, so you probably can see I don't have 30 years of PLC programming experience. Can't make that up. But we have a lot of people in our project that have that. When we started out, we had about 1,000 people registering on a platform, discussing about the top 20. And after we released version 1 of the top 20 secure PLC coding practices, we created a small core team to maintain them and to operate the surrounding projects. And that small team has since grown to 75 people again. So again, that's not a small team anymore. Also, we've been spending a lot of time translating them because engineers usually feel most comfortable in their mother tongues, mother languages. We've been working about 15 translations. I think 5 are already public. There have been numerous presentations about the top 20. There have been trainings. There have been virtual machines where you can try out some of the things. We've been approached by vendors, operators, and integrators how to implement them. We talk about that one later. And we've got a lot of organizations who want to adopt them or have already adopted them. So MITRE has approached us to adopt the top 20 into their CWE framework. The ISA has created a micro-learning module around the top 20, Dan Ehrenreich. NATO has included the top 20 in their cybersecurity guidelines. And also, since we're here, CSA has included part of them in their cybersecurity code of practice, version 2. And since that project has really created a lot of interest, there's been a lot of buzz about that, I feel it's the right time to clarify a few things, maybe to eliminate a few misunderstandings in 4 areas. We're going to look at the top 20 from 4 perspectives. The first we already finished, almost. So the top 20, first and foremost, we limited to a limited scope because we didn't want them to water down to resemble any normal OT cybersecurity guidance. We said, okay, we need to limit the scope, and we limited the scope to anything that can be changed directly in the PLC, because obviously there are a lot of things you can do to increase PLC security that are not directly in a PLC. And those ones we cut out from the list. Also, what's important to me is the top 20 are, again, a community project. They are not a scientific project. They are neither complete nor are they validated. And also, they're not a standard. That's an important one. They're not consensus-based. There have been a lot of opinions on that. It's a lot of people working on that, but there's no consensus-based process behind that. They're not a standard. We didn't want to create a standard, not yet another standard. Second up, what we were going to look into next is security capability perspective, and that's a good opportunity to at least have a quick introduction of what's in the list, because I'm not expecting any one of you to know it by heart. And we look into the list by security goal. Top 20 mainly follow 6 security goals, which are integrity, monitoring, hardening, and resilience. And you see there's a slight imbalance towards integrity here. Reason is that we split integrity into 3 parts. First is the integrity of PLC logic. We said, okay, what can you do about integrity of PLC logic? The first you see here is the most obvious choice, cryptography or checksum integrity checks. Obviously, you can't always implement them on PLCs. So the next 4 options are things that you can implement in order to have a method to have more awareness about logic integrity without really having integrity checking mechanisms that you know from IT. Second is integrity of PLC variables. And since PLC variables are a lot about what you input to the PLC from externally, that's a lot about input validation. And for input validation, what we did is, again, keep in mind these security decisions be as pragmatic, as practical, as concrete about what exactly you can validate in a PLC, what's worthwhile validating, and that's timers and counters, that's paired inputs and outputs, it's interactions, its HMI input variables, and also makes sense to have a designated register block for validation purposes. Next up, integrity of I/O values, and here is where the PLC characteristics come in. The PLC is always connected to a process, so the best way to validate any input-output values is really based on the process, on physical plausibility, so you should be doing that. And then the three gray categories are probably not that surprising. It should come at no surprise that you can do monitoring for PLC as well. More important is what you can monitor, and that these things that you can monitor, maybe you are already monitoring, can also be security relevant. They can be used for security purposes. So it's monitoring cycle times, monitoring uptime, hard stops, PLC hard stops, memory usage. We will come to that in a minute in a bit of more detail. And the last two, hardening. Well, first of all, a PLC is already a pretty specialized device, so there's not that much to harden normally, but you can always harden communication to external interfaces. That makes sense. And resilience, that's an important one because an important threat vector to a PLC is to simply crash it. And when it crashes, it needs to be restarted. So it definitely makes sense to think about safe restarts for PLC. And that also is a security resilience measure. So now you've seen that what's in the top 20 list, roughly. More details are on a link you see at the end. And next up is what they are not. You see that they are focused on integrity. That's no coincidence because that's simply something that you can achieve with a PLC. You can focus on integrity, you can improve integrity, and also that's arguably the most important security goal for a PLC. What they are not becomes more clear when you look at conventional IT secure coding practices and try to apply them to PLCs, because then the limitations become very obvious. And conventional IT secure coding practices, examples we have here, have been published by Microsoft, by Carnegie Mellon, by OWASP. And what's important about that is we have to keep in mind PLC specifics, PLC characteristics when looking at them. We do that shortly, a simplified PLC architecture you can see here, and the important part about a PLC is it mainly operates in 4 steps. It reads inputs, it executes logic, it communicates with external components, and it writes output. And this is how PLCs ensure their most important characteristics. This is how they ensure real time, because they have all these 4 different steps, have allocated time slots, and they can't last any longer than these time slots. And real time, that's an important misunderstanding. It's not about being fast, but it's about being fast enough for a certain process, be it milliseconds or hours. It's also how they ensure determinism, so that you, whenever you feed it something, each time you will get the very same output. And these are important things to keep in mind when we now look at the IT secure coding practices. We have 4 different groups. We can group IT secure coding practices in 4 different groups when we try to apply them to PLCs. First is they are applicable, and we can be even more specific about them because of that specific PLC architecture. An example for that is monitoring and logging. So, for example, we had that example before, cycle times. It makes sense for a PLC to monitor cycle times just because they're always so similar. Because cycle times are always so similar, if the cycle time changes significantly for a normal PC, that wouldn't mean anything necessarily. For a PLC, that's an indicator that probably some of the logic could have changed because there's not many more reasons why the cycle time could change. Similar for memory usage, there are other examples. Then there's a group of IT secure coding practices that is simply not applicable to PLCs. So for example, the principle of least privilege for processes is an important IT secure coding practice that just doesn't apply to PLCs because you've just learned PLCs just prioritize processes differently. Session management doesn't apply if you don't have sessions, and so on. Third, not in scope, that's an easy one. There are some secure coding practices that frankly are not really coding, and as we said before, we want to focus on anything that is really done in the PLC, so anything that's focused on asset management or on test environments or on change control we didn't include in the top 20 list. And that's The very last category is the most important here. That's the ones that are not technically feasible. And these are measures that are common in IT secure coding practices that are important, that would be very important for PLCs, that would be very good candidates for the list, but which we simply cannot assume to be present in today's PLCs because they simply don't have the technical capabilities for that. And at some point in the project we said it doesn't make sense to prescribe anything where we simply, with today's PLCs, it simply doesn't work because today's PLCs, as we all know, will be in the plans for decades to come. And if we now put in the coding practices that only works for 1% of the PLCs, if at all, it doesn't make sense to put that in. So that's why you don't find anything about authentication from PLCs or PLC protocols on the top 20 list. So security capabilities perspective, the top 20 mostly improve integrity. They are different from IT secure coding practice in that they are tailored to PLC specialties, and that makes them very practical, very concrete. But they're also limited by the assumption that we assume the capabilities of PLCs that are on the market today, so some of the very important features are not found on that list, and that's why. Next up, threats perspective. So what kind of threats can you actually address with the top 20? So first things first, we've been asked by journalists a lot when the top 20 came out, would this have prevented Stuxnet? No, that's not the case. But we can, again, group the kinds of threats that we can address in different categories. So first is anything that involves sending unexpected packages to PLCs. That's the famous ping of death, where a PLC simply can't handle ICMP packages. It's memory overflows or kind of memory overflows. It's anything that causes denial of service. These are not unimportant threats because these are really common scenarios how PLCs can be attacked. It simply causes the PLCs to crash. And these things can reasonably well be addressed by the practices that we have in here because a lot of things are about input validation, are about monitoring of integrity, and these are really things that can be caught by the top 20 that we just introduced. Next up is two groups of threats that we somehow implicitly address, but to be honest, I think we could do better, and that's something on our list for a potential version 2. A group of threats to PLCs is causing indeterministic results. As we said before, PLCs, a main characteristic of PLCs is that they are deterministic. Whenever you feed it something, you get the same output for the same input. And there are some conditions in the logic that you could cause in logic that may cause indeterminism. And that's something to avoid under our circumstances because that's really so important for PLCs. Examples could be race conditions where it depends on which of two branches is executed faster. It's bypassed or duplicate instructions where you're not sure which one is actually executed. That's something to avoid, obviously. Second example is any situations where there's undefined code in the PLCs. There could be hard-coded parameters, undefined variables, anything that can easily be rewritten by an attacker and then changes the outcome of the PLC. Also, that's something, both these categories we somehow implicitly address with our top 20. Of course, input validation helps. Of course, anything that addresses integrity helps. I think there may be opportunities to address that more explicitly by more explicitly saying what you can do in the code against these two kinds of threats. We don't yet. That may be something that we could change in the future. And again, the most important category is the third one, these that we don't address. And this is probably the most important threat scenario to PLCs. The one where you just abuse normal, legitimate features. You could say by being an inside actor, just with the exemption that you don't have to be inside because PLCs don't have authentication. So you have to be inside the network, but you don't have to have insider knowledge of any credentials or anything because they're lacking authentication. And that's what's been called insecure by design. That's what's been called forever days. That's the big problems we have with PLCs, that we've been having with PLCs for 10 years and more, and that's the really important thing to address. I would love to tell you that's all solved with the top 20. It's not. We cannot solve that, right? We said that before. The only thing that would really help against that, against a normal engineer being replaced by a malicious actor, abusing normal features because they have no authentication, that we cannot address. A good example for that, as we heard earlier today, Pipe Dream. That was also something that didn't really use any fancy vulnerabilities, right? You could, in a way, you could just say Pipe Dream was a more sophisticated or maybe even more easier to use engineering tool than the engineering tools that you have right now. It wasn't more, but that is already something that is really dangerous to PLCs, right? By coincidence, it targeted Schneider Electric PLCs. Normally, you use like 5 different engineering tools for 5 different PLC brands. If you have a like hybrid engineering tool that you can adjust to all kinds of PLCs, that's something that operators would probably love as well, and attackers have that. That's a problem, right? If PLCs allow any action that normal engineers can do, you allow basically anything. You can allow, you can upload logic, you can download logic, you can change firmware, you can change set points, you can do anything you want, and that's not something that PLC coding can help, because you need features in that, you need features in authentication in PLCs, and you need authentication in PLC protocols, and the top 20 cannot do anything about that, unfortunately. So, summary, let that sink in for a moment. We can address unexpected input threats. We can partly address indeterministic output or undefined output. We cannot address the most important threat there is today to PLCs, at least not in terms of consequences, the most important. Lastly, I promised we look at implementation as well. I think that's an important part because that's one where maybe most of the misunderstandings were or are. We have a split by the top 20 here, roughly what we estimated who can implement each of the practices. And when we look at the diagram here, we see that we have an issue because asset owners are understandably the group that is most enthusiastic about PLCs, about PLC security and about the top 20. Understandably, because they're the risk owners, they have to care about PLC security. And yet, they are not the ones that can implement most of the top 20, at least not alone. They need the help of an integrator or vendor for most of the top 20. And that's an important message because I also think in the project, we have more asset owners and service providers than we have vendors and integrators. We really need more vendors and integrators to be integrated in that project and to be helping our PLC security efforts. We have 2 things that we call asset owner empowerment tools. There are no magic, of course, but they are a bit of part of the surrounding projects that I mentioned earlier around the top 20 list. First is, if you're an asset owner and you can't implement things yourself, what do? You try to mandate your vendor or integrator to do it. So we can't really help much with that, but what we created is a template for creating vendor policies that include the top 20. And also, a very recent addition that's really close to my heart is the top 20 secure PLC coding practices application notes. That's where we try to make it very easy for asset owners, yes, but more importantly, integrators and vendors to make transparent how they approach PLC security. So we try to make it very easy for them to say, this is the things that we do, this is the things that we don't do, and here's why, for a certain use case. And the important thing is not to tick every box. The important feedback that asset owners need, but also that we as the top 20 project need is, what of this works, what doesn't work, what have we done for years and really don't need in that list anymore, and what can be changed. And we need a better understanding of what's out there in the PLCs already. Maybe some of the asset owners, some of the integrators and vendors do all the things all the time, but they don't talk about that. Start talking about PLC security. I'm very sure your asset owners, if you're a vendor or integrator, probably it's not that much in the room here, but maybe virtually, I don't know. If you're an integrator, try to do that. Try to communicate how you approach PLC security. Your clients, your asset owners will definitely love you for that. So we've got the first example. I'm almost promising all integrators and vendors who help us in filling one of those out that we will get them their logos on everywhere. The marketing would talk about them. So here's Grantech. That's the first integrator that actually filled that out. They said, okay, we take in an anonymized use case. That's a North American pharmaceutical manufacturer, and we just make transparent how we use the top 20, how we approached PLC security in our projects based on the top 20. Is really just 2 pages to fill out to make transparent, and something that helps asset owners tremendously. The template is available on our website. There's a big group of volunteers that help you with filling that out, so that's something definitely to consider. To wrap things up, here's a small timeline of PLC security. So, as I said before, our assumption is for the top 20 project that PLCs, as we have them on the market today, are insecure. We would all like to be that for that to be different, but we can't change that. So that's our assumption. So what we can do, honestly, is just compensating controls for insecure PLCs. First is compensating controls around the PLC. They're first on the timeline because, honestly, that's your lowest hanging fruit. Your lowest hanging fruit is not changing things in the PLC logic. Your lowest hanging fruit probably is, from a defense and depth perspective, all the best practices you already know. Right? So that's just a few examples: organizational practices, network, physical, recovery. That's all things you find in every OT cybersecurity best practice guide, and they're also good for PLC security. So if you're an asset owner, do this first. And if you finish doing that, then you can turn to compensating controls in the PLC. And that's where the top 20 are. So the top 20 are not the first thing to turn to if you're just starting out doing cybersecurity. They're probably midterm, and they're assuming imperfect PLCs. And for that, they're the best thing probably that we have right now. And third, of course, is dedicated security features in the PLC. That's where we want to get from a security perspective. So that would be, again, authentication in PLCs, authentication in PLC protocols. It would be secure boot, it would be signed firmware, it would be logging, it would be access control list, and maybe most ideally, it would be something like self-aware PLCs. So PLCs that actually know what's running inside them, and they know when something is different and when something is malicious. So that would be the target. If you're an asset owner, integrator, or vendor, last thing to do for today is, what can you do depending on your role? If you're an asset owner, we said that before, your first job is implement your compensating controls around PLCs. Surround the PLCs with security. That's also good for PLC security. The very first thing to do, and you can also do that primarily by yourself. For the top 20, implement what you can. We've seen that asset owners alone cannot implement all of the top 20 on their own, always depending on how much PLC programming you actually do yourself. I realize that's different, can be different. And also, for what you can't implement yourself, request your vendors and integrators to implement that. That's where we have the cybersecurity vendor policies. So remember the asset owner empowerment documents. But for the dedicated security features in the PLCs, you probably can't do much more than talk some more, right? You have to request that. Wouldn't be the first time where pressure from clients, from asset owners, would drive security and vendor products in the right direction. But I'm not going to lie, probably it's also going to take some kind of regulation for that one. In Europe, at least, we are currently starting to have some regulation about secure components for critical infrastructures. It's not yet covering PLCs, but maybe we're getting there at some point. Integrators. What you can do is, for compensating controls, implement what you can. Obviously, you can't do anything. You can't do everything. You need your asset owner for that one. Compensating controls in the PLC, the top 20, that's your job. Whenever you deploy any PLCs and you program them, take a look at the top 20. And what else is your job is communicate. That's the application notes again, right? If you do good stuff, talk about it. If you approach PLC security, if you take PLC security seriously, make it transparent to your asset owners, make it transparent to clients, make it transparent to your peers. And also for the dedicated security features, what again you can do is talk, and talk some more. We had that before. Last up, vendors. Well, basically saying the same things as for the integrators with one big difference. The dedicated security features in the PLC, please start doing that. Please start thinking about that, implementing that, and if you don't know where to start with authentication. Everyone is going to love you for that one. That was the 4 perspectives. So summary, implementation, the PLC's secure coding practices are not your first measure for security. You're not the lowest hanging fruit. They're midterm compensating measures for imperfect PLCs. But for that, they're helpful, hopefully. They can't be done by asset owners alone. They need vendors and implementers and integrators for implementation, but at the same time, they need asset owners to push because they are the ones that are the risk owners and that care most about PLC security. And also, the top 20 projects are a conversation starter. They're not meant to be a conversation ender, right? So they're a volunteers project. They always need more volunteers. We're trying to make security decisions that engineers, automation engineers are making any day, every day anyway, visible for PLCs. And whenever you have something to contribute to that, whenever something that you've seen here is controversial to you, or you want to make better, or you want to improve, or you want to work on a surrounding project, please reach out. Here's the relevant contact data. And now I'm looking forward to the panel discussion. Thank you.
Thank you very much, Ms. Sarah Flus. Please take your seat for the discussion coming up. As I invite your fellow panel members to join you for the discussion on the undetectable PLC attack. Ladies and gentlemen, I invite Dr. Ong Cheng Hui, Assistant Chief Executive, BizTech Group of IMDA and Covering Director at Trust Tech Engineering. Also, Mr. Dale Peterson, Founder and Program Chair, S4 Events, as well as Founder and CEO of Digital Bond, and Mr. Joel Thomas Langle, Founder and Managing Member, Industrial Control Systems Cybersecurity Institute, and Founder of SCADA Hacker. And moderating the panel, we have Mr. Paul Griswold, Chief Product Officer, Cybersecurity at Honeywell. Mr. Griswold, please.
Great, thank you so much. It's great to be back in Singapore. Singapore was actually the last trip I did before COVID, so I was here in March of 2020. And I remember talking to my colleagues about how I'd be back soon because this COVID thing was only going to last a couple of weeks. So I went home, I worked for 2 years, and now I'm back here, so I'm very happy to be here. We're going to start our session here with a quick poll. So this will be coming up here shortly. If you use the Slido app. There we go. So the first question is about the average age of the PLCs in your environment. So we'll give about 45, 60 seconds for everyone to do that. Nice. Very professional. All right, we'll give another 15 seconds.
We don't know how many submitted.
All right, looks like we're slowing down. I'll go ahead and close the poll. So if we take a look at that, about 70-something% over 10 years old. Panelists, does that surprise you at all? No, I wouldn't be surprised either. So you're dealing with some pretty older technology out there, generally at least 10 years old, and typically those types of things are deployed for at least that long. Let's take a look at the next question.
As we're waiting, Paul, I kind of think that that number correlates to the age of the infrastructure that they're put in.
I'd imagine so, yeah.
Right.
Definitely so. So we're already up to 60 responses here. About 50-50, a little less than 50-50 in terms of whether or not you've maintained your PLCs with regular firmware updates. Looks like this one's holding pretty steady. Going down a little bit on the yes side. So well over half of the PLCs out there are probably running the firmware they came off the factory floor with. All right, let's take a look at our last question. Who performs the majority of the reprogramming? Most of the people, service providers. So I think as Sarah was talking about before, this is something that's not typically in the control of the asset owner. It's generally going to be a service provider or an integrator or a vendor. So, wow, pretty serious stuff. So let's start the questions here. So Joel, I'd like to start with you. I know you have some opinions on the top 20. What do you think it gets right, and what do you think it gets wrong? Sorry, Joel.
Me? Well,
Yeah, Joel.
so no, the polls were actually really what we were expecting to come out, because I think it's a great idea. It's a great initiative. For me, as a vendor forever and now keeping close relationships with industry, PLCs are really not considered a disposable product, which means we don't tend to upgrade and replace those as often as some of the other products in the installations. I mean, DCS is you'll see DCS controllers that are 20, 25 years old, and there's not a lot of justification behind replacing them. And you can argue both sides of this, and everybody would, but sometimes people would argue that what we have from a functionality, longevity, reliability, robustness is probably better from what I could buy 20 years ago than what it is today. So I think that's going to be the biggest challenge, is getting the need to do it. And one of the questions that I would kind of throw back was that Marco and I were talking, and the biggest challenge is me being in all three of the triangles, asset owner, integrator, and vendor, is that I'm curious where the responsibility comes for even asking for it, because this was always the argument or discussion when we would meet, and the difference between private sector bidding and government bidding is that government bids tend to be fixed fee, where private sector bidding tends to be lump sum turnkey. So if it's not spec'd and requested, it's not going to get supplied because we're nice people, because with e-bidding procedures today and everything else, you can lose jobs on 1%. So I kind of would say that the challenge is really on making sure that people start to ask for it and where that requirement's going to start.
Great. Sarah, given the amount of brownfield that's out there, how long do you think it'll take before we get critical mass for the top 20, for most of the vendors to actually implement most of the recommendations?
Well, as we've seen, the PLCs that are implemented today are mostly more than 10 years old, and I think that comes as no surprise for anyone here in the room that they're old. What they intended to do when the top 20 started is we didn't have the illusion that we published this and then everyone would follow that and all PLCs would become secure like this. It doesn't work like that. What we hope is that we, at least for all the people, that gets to the question how to implement the top 20 in the brownfield environments. Whenever you do have the chance to change something in the PLC, you at least know what you could change in order to increase security. That was the goal of that all. The goal is not to say we need for all existing PLCs, we need to mandate certain requirements. It doesn't even say requirements anywhere, right? It's a collection of tips and tricks, as Jake Brodsky said initially. So the important thing is that at least people who want to do something about PLC security and who want to program PLCs and who are responsible for programming PLCs have an idea what are the small design decisions that I have to make when I want to care about security. That's the goal of that all. So the goal isn't at all to say, rip out all your brownfield PLCs and do security. I know that PLCs have a different job than to be secure, right? And that's the more important job. But if you want to care about PLC security, we want to have something at hand that enables people to care.
To go back to the question, how long do you think it's going to take? Do you think it's going to be 10 years in the next refresh cycle? Do you think it's going to be 20 years before?
Well, if I'm optimistic, I'm saying, well, now it's out there, so all the vendors and integrators know it's out there, so whenever they implement a new PLC, voila, that's it. If I'm realistic, then probably it's going to take one cycle more because it's out there. What we always see when there's security issues that vendors and integrators have to address, that's asset owners have to drive that. So first, asset owners get regulated. They need to realize what's important. They need to require that from their vendors and asset and integrators, and then in the next cycle, integrators and asset and vendors come to the table. So probably it's going to take at least one cycle longer because first the asset owners need to realize, the asset owners need to implement that in contracts and require that, and then vendors and vendors and integrators need to start thinking about that and implementing, and also they do have existing libraries. It's not something that you can change from one day to the other, so it's going to take a lot of time. That's probably also a good thing, because our top 20 are by no means completely mature, right? So I'm under no illusion that there are a lot of things that we can improve and that we can, as I said before, there are maybe additional threats that we could address. So maybe it's a good thing that we start the conversation and we have in parallel, we get more mature, the top 20 get more mature, and the integrators and vendors get more aware, and maybe at the same time we are mature and they are aware, and then they can implement. That would be my ideal. Okay.
Can I chime in on timelines? It's funny, I saw Eric Byers, who wasn't able to come here as one of the panelists, so I saw Eric do a demonstration with Modbus and show that it was basically insecure by design at an ISA meeting in 2003. And in 2003, I was told, it'll take a decade until we fix this, which was kind of Sarah's last column, you know, where we actually integrate the security features. So a decade later, we did Project Basecamp, and we said, okay, it's been a decade, we haven't gotten anywhere. This is how bad it is. We made a very vivid example, and now we're a decade later, and we still haven't made any progress on this. I've waited for government or somebody to stand up and say, we are actually going to solve the core problem and add authentication to this very important thing. I mean, it's mind-boggling that it doesn't have authentication 20 years after we started. But here's the good part. The things that this project are doing don't require that overhaul. So it's not this step change. So I'm much more optimistic about what we're seeing here, also because there's some benefits to it. We didn't even, I think, maybe you even undersold it a little bit, Sarah, in terms of detection. A lot of these controls offer detection possibilities. And as we have more events, we'll be able to tie things to this list. For example, the Oldsmar water treatment system, where the adversary wanted to dump a bunch of chemicals into there, much more than would ever be required. The top 20 would have said, yeah, maybe he could do it on the HMI, but the PLC is going to stop it. So I'm encouraged that we're going to see some near-term progress in this, even if we're not going to get to the end column. So from a practical standpoint, I'm very encouraged by this.
So, of course, I'm going to challenge Dale on about everything he just said. So, first of all, I don't believe that anybody should touch Modbus because there's no reason, because we can accomplish the security with compensating controls that have been around for 15 years. So put in a Tofino or any one of probably a dozen other products that are made. If you can't secure the product, secure the conduit into the product. And I'm not saying you need a Tofino for every firewall or for every Modbus TCP device, but you should certainly have them to provide the communications in and out of the zone where these Modbus TCP devices reside. Because with one of those devices, it's very easy to do either hardware or network address filtering, so you're doing a source and destination lock, And with the deep packet inspection capabilities, you can limit the functions codes that are allowed. So you can control who has read capability, who has write capability, who has program capability. And that's like the third question that's on this list. I don't know who's on any of the other ones. So with Modbus TCP, deal with it. I mean, nobody really gives the statistics of how many people are still really using Modbus TCP versus more of the current next-gen protocols that start to address the security deficiencies of Modbus.
I heard a lot of complexity there in all these add-on solutions that you were talking about. But in the end, I don't want to divert us too much from the PLC Top 20. I think you're probably right. As much as I would like to see it and have been harping for it for the last decade, I don't think we're going to see integrated security in the PLCs, in the level 1 devices, until we have a step change in the technology, till we start to say all these things except for the I/O are moving to containers. I think once you see that, then you're going to see an overhaul, and that's when we'll bring in the security. It would be curious. I noticed in the, I'm not going to put them on the spot, but in the poll, 2 of the people bought their PLCs in the last 2 years, 2 of the people that responded. Some of the PLCs now have security features, and one of the things that I'm asking the vendors is, when you have these new security features, are people using them? And the answer is unfortunately no. So we're not going to be able to blame the vendors if the asset owners choose not to implement security features that are available, because they're a business. They're going to give the customer what they want.
Dr. Ong, Dale had mentioned something about regulatory and government and type regulations like that. Do you have an opinion on that and what the role of regulations are in helping to solve this problem?
Well, I think regulations is actually quite a heavy lever, and we should use it sparingly, right? So I think in the previous panels, we have been talking about the CCOP and whether we should use a CCOP to implement controls and all that. Well, to me, if it is about a known attack, then yes. So we should definitely be implementing some of those compensating and security controls around it. But there are some things that where the technology may not be fully mature. We may not fully understand whether some of the technology has fully covered the space, or is it covering it adequately, right? So when the technology is in the process of maturing, I do think that we shouldn't be over-eager to throw in regulatory levers at the problem, right? There needs to be that balance between allowing innovation and the maturing even of security controls before we put that as a cost and as a requirement that the business then have to take up.
Okay, great. Looking at the questions that are coming through Slido, if there's anyone in the room who'd like to ask a question, we have mics set up, so please feel free to come up. But in the meantime, the top voted question so far, how do you suggest implementing the top 20 PLC coding practices retrospectively on brownfield systems that have already been installed for a long time? Maybe another variant on that, what are some of the most important things to implement first on brownfield systems? Open that up to anyone who wants to answer.
For me? Yep. Honestly, if I'm asked, how do you suggest implement top 20 in brownfield systems, I would say, well, don't. I mean, you can, first of all, if you remember that timeline, do everything around the top 20, everything around the PLCs. These are your low-hanging fruits for making PLCs more secure, and if you're done doing that, you can consider doing the top 20. And then also, I don't completely buy the story of we can't touch anything and we can't integrate any of this because our PLCs are have been running for 10 years. Because honestly, we get very mixed feedback on the top 20, and that makes me wonder. There's one camp that says, what are you writing down there? We've been doing that for years anyway. That's just normal engineering knowledge. And the other camp that says, that's so much extra work, we will never be able to be doing that, and besides, we've been running PLCs for 10 years, we can't touch them. So probably the truth is somewhere in between. And probably the truth is that, as Dave said, there's a lot of detection things in there that don't necessarily change logic. If you do have the capacity to worry about PLC security, if you have done all your low-hanging fruits surrounding controls, there are definitely things in the top 20 that you can implement without changing much of the logic of the PLCs, right? You can think about the easy things, monitor cycle times, monitor memory usage, things like that, that just help you being more aware when something happens to your PLCs. That's maybe the easier ones. Pick the ones that are easier to implement. That's something you can definitely approach. And if that's all too hard and you can't touch PLCs in the process and you can't change anything, you really can't, be honest to yourselves as you really can't, then just wait for new PLCs to come in and just don't implement it in a brownfield. That's an option, right? PLC security is probably not your biggest problem out there. Yeah. But if you want to do something about PLC security, well, here you are. There's something you can do, right?
Dan?
So I'm going to throw out, and again, we kind of were talking about this in advance, I'm going to throw out this systemic discussion that people think PLCs have to be secure in the first place. PLCs are not typically deployed in high-risk areas. If they're high-risk areas, today people would deploy a small DCS that gives you everything the top 20 asked for. So if you compare the price of a small Delta V control system, which is far easier to configure and program than it is buying a PLC and then buying a SCADA package and having to configure the logic in the PLC and then separately configure the SCADA system, most integrators today are going for the DCS vendors' small packages. So I don't think that every PLC needs to be supplied in a secure manner because a lot of people put them in truly standalone fashions. So that's why it's always been this push that we have to make everything secure. It's risk-based on the implementation and what the asset owner is doing with them. If they choose to buy a Siemens S7 1200 and put it on a network that doesn't have any access control, they're going to get hit. But that's not Siemens' fault. That controller costs $175. What do you expect for $175? They bought it to do a simple task, which it does. If you wanted to do it securely, you might have to add a couple zeros to it. And that's where we're trying to say, spend $7,000 rather than $500 on the controller, and you'll start to see a lot of those features. Over.
Dale, Dr. On, do you agree with that?
Of course not. That's why we sit next to each other. We take this act on the road. I think that's really sector specific. I mean, I have been in many large plants, manufacturing, a lot of manufacturing that has many, many PLCs from Rockwell, from Siemens, from others. There are probably sectors where what you're saying is exactly true. So I guess I would say that. And the other thing that, as you were saying that I was thinking about was when you start to talk about this cost aspect, and if we look forward to the future, we're talking about a lot of IIoT stuff that is not, quite frankly, a PLC, but is doing some of those features and functions, and you get this, what's the difference between an edge device and a PLC and one of these IIoT things? And I think the cost aspect can't be the criteria as to whether we should be securing it or not. And I guess you didn't say that. You said it was risk-based. So I think you're right. But I guess in general, I think you really have to look at your sector. There are some sectors running a lot of PLCs.
Got it.
So I think there are two things. One thing that I want to react to, you said, and I totally agree with that, PLCs do not exist to be secure. But let's think a moment and think, okay, what technical component exists to be secure? I mean, security is always just something that comes on top for something that has a different job. PLC has the job to be real-time capable and to run a process, but so has a DCS. DCS doesn't exist to be a security device either. And also, none of the top 20 says, do implement this on every unimportant PLC in your network. Please don't, yeah? The risk-based approach is totally viable. That's totally okay. But if you have the requirement for certain PLCs where maybe you have in your CCE high consequence events and you say, okay, this is something where the PLC is really at risk and where I want a secure PLC, you need answers how to do that. And this is what the top 20 are for. They are not for, this is, baseline for and you have to follow that for every single device and every single configuration. I don't think that's necessary. It's necessary in a world of unlimited budget, which we don't have. So
honestly, if we look at the trajectory of some of the cybersecurity, right? So when we moved from SHA-1 to SHA-2, that actually took the world 15 years. And we're talking about software systems. So if we are talking about PLCs where there's mission control and it's mission critical and there are safety critical systems in there, I think realistically, we will expect that the adoption itself is going to take some time. I think the question is really, what can we really do right now in order to mitigate some of the risks that the top 20 practices kind of let us know about? And I think this is the part where I thought, Sarah, you were kind of underselling yourself. Because I thought what the coding practices actually do is that it increases awareness of what can be done, right? And it generates that debate that it's not just about good coding practices, but also about good audit trail practices, right? Of making sure that things are actually being logged, what can actually be logged. And that creates an awareness. Now, what that awareness actually leads to, whether it's about the blanket adoption of the 20 practices or selective adoption of the 20 practices on the brownfield systems, because we managed to find a way to work with the vendors to kind of introduce whatever is possible within our environment, I think that is also something that can be considered. So it's not, it may not be just a binary thing.
The thing that I'm worried about is that security is all relative to a snapshot in time. So 25 years ago is when we made the decision to leave proprietary and go COTS. And that decision was made largely in part with the release of Windows NT 3.5.1 and 4.0, which at that time was deemed the most secure operating system ever released. It had US Department of Defense Orange Book qualification capabilities. And we look at it today, and it's a joke. So who's to say that if it takes 20 years to get the PLCs, that what we're saying today makes a secure PLC will represent security 20 years from now? Because I'm confused at what we're calling a coding practice versus a PLC's base functionality. Dual-factor authentication has nothing to do with coding. It has to do with the development of firmware and hardware associated with it. But the way you write code is something that we could do something about today. Why did you intermix coding practices, which is what an integrator does, with hardware requirements that the vendor has to provide? They're kind of very different. Was there a reason why they weren't split?
That's a very good one. And if I would be able to change that right now, I would do that. But we had, as we said, we had a big server where we collected all the kinds of practices that would be remotely relevant to secure coding. And at some point, they were really just a huge mass of everything that would be relevant to OT security in general. And then we said, okay, we need to limit that scope. I think it was initially Dave's point. We need to limit it to something, and we wanted to make it an easy delimiter. So we said, okay, at least it needs to have to be something that can be changed directly in a PLC. That's where we ended up with. I also think when we look at it now, 1 year later, as the examples I showed today in the slide, I think there are things that are even more coding that are not in the practices yet, that maybe didn't come to our minds, or we didn't have any practices submitted in our 500 practices that we sorted out, that would be even more coding. It started with, and maybe that's also one reason why it has this coding title that may be misleading, but what we wanted to do is the analogy to IT secure coding practices. And to be fair, if you look at IT secure coding practices, they are even less coding than the coding practices we put in there for IT. So the examples I showed before, in IT secure coding practices, you find asset management. Well, that's not coding at all, right? So that's even more vast and even more unbalanced. So I would be totally open to saying, okay, in version 2, let's really focus on things that are coding, that are really programming, and the rest goes to a second list. We already have a second list that we plan. It has the working title, Secure PLC Environment Practices, so everything that creates a secure environment for PLCs. And maybe what you said is even a third topic, right? So hardware things and things that vendors and integrators can do. But in the end, what we're having here, and I can't emphasize that enough, is a community project. So, like, I'm not the master of disaster and say, well, this belongs here and this doesn't belong here. So we have to find some kind of agreement on what we want to have in there and what we think are useful tips and tricks. That's how we started for PLC security. But that idea of keeping it more strictly to really coding, even more strict scope than we had before, would be one thing that we could consider for version 2. And by the way, I would be most happy if people who have ideas for that, like Lou, Joel, contributed to that and said, well, I have ideas what real coding would be and what would be manageable and doable. There were even ideas to say we split that list up between vendors, integrators, and operators. But we didn't want to prolong version 1 for another 5 years until we are happy with every word. So that's why we didn't do that. So I totally agree to that criticism. It's not all coding. No, that's not. It's not. Definitely not.
Did the project ever take the PLCs that are on the market and rank them against the 20? So right now it's like, it's still gray. So has anybody actually just said, we're going to take a look at the top 5 models of Schneider Modicon, and we're going to take a look at the top 5 models of Rockwell and the top 5 models of Omron, and go down the list. Has anybody ever considered that so that it's not a completely white sheet of paper for people that have never seen it?
We have one idea of like having versions of the top 20 or having guidance for the top 20 for, let's say, as you said, do this for a Siemens PLC, do this for a Rockwell PLC, do this for, because obviously, and that was also a big discussion point we had in the top 20 team, mostly in between European members and American members who said, well, in Rockwell that's different, and the European one said, in Siemens that's different. So we always had these two camps, and it was really hard to reconcile. So probably you could have 2 completely separate lists for Siemens or for Rockwell PLCs because things are just work differently there. And I would love to have that. We just need the people to put the work in because this is a volunteers project. There's people investing their free time. And we have too little vendor participation in there. My favorite idea would be, and I actually try to bug Siemens and Rockwell people into getting into that one, would be vendors who really know how things are done and who may already do all the things that we have in there, say, okay, this is how it's done in a Siemens PLC. We have some examples in some of the practices has implementation guidance, and in some of them we really have examples with screenshots. This is how you do it in a Siemens PLC. And it would be really great to expand that to like 5 different standard models and say, these are the boxes to tick. But that's something that's a lot of work, that requires a lot of experience, and is probably difficult to maintain. If you get the manpower to do it, and if we have a large enough community which says, well, let's do it, then I'm all in for it, definitely.
How do you think you get more vendor participation there? I mean, there are a lot of vendors out there. They all get Dale's newsletter. Why do you think they're not participating a little bit more?
Honestly, I don't know. I have the feeling I keep repeating this since the project started. We need vendors, we need vendors, we need vendors. Vendors, where are you? And my guess would be it's the same like we see in critical infrastructure regulation in all countries. Who gets regulated is the asset owners. The asset owners have the requirements, and the vendors only start to care as soon as the asset owners trickle down requirements to the vendors. Mm-hmm. So probably that's the same way we have to go with the top 20, with the problem that we're a community project and no regulation authority. So we can't say you have to do that, and honestly, we're not mature enough to mandate anything. We don't want to do that. And also, I think vendors, at least I can speak for Europe, with all the legislation coming up on secure components anyway, they're really careful not to move before they really know what they have to do. because you don't know yet what standards will be needed to follow for regulation. Some follow ISA 62443, some have certificates for that one, and no top 20 are another issue to come up. And as a vendor, I can partly understand. I wouldn't invest a lot of money into complying with any kind of list or standard until I know which one now is the one to follow, right? That's why we're trying to make it uncomplicated and unbureaucratic to say, here, application notes, just tick a few boxes and fill it out. We even have a team of volunteers who would happily assist and help you, and you get a lot of social media attention and say, hey, look, a secure PLC vendor, because that's something that everyone would be wanting, right? So I really think the problem is interest. Asset owners have the largest interest in doing that, and vendors have a lower interest in doing that. One thing that has been mildly successful is speaking about the top 20 in users meetings. So in users meetings for different kind of PLC vendors, and then again we have the problem, there are a lot of different PLC vendors and they all approach things differently, so that's really something that has to take time and that has to take volunteers that we have ready-made slide sets where you can present the top 20. That slide set that I showed today will be up for our team for anyone to present. Anyone who here in the audience or anywhere stands up and says, I want to be an advocate for the top 20, give me the slides and present it in my local users group or anywhere. Take Black Hat, I don't care. Take that and go for that. We really support anyone who wants to do that. We don't have any spokespersons who are the ones that can talk about that. Really, we want to spread the word. We have the most permissive license on all that document. We put all the material out there, but spreading the word, I think, is something that needs to be done one local area, one region, one users meeting at a time. And another issue is that most engineers are organized locally, regionally. There are regional differences. The US employs different PLCs than Europe, and probably here they're different as well, and also in every sector they're different. And then many engineers, at least in Europe it's that way, are not comfortable speaking English, and there are all these small barriers, and that means that it has been way more effective to talk about the top 20 in small regional groups and users meetings than at the big security conferences, because you don't reach the engineers there. They're not at Black Hat. They're not sitting at Black Hat and waiting until somebody maybe talks about PLCs. You need to get to the users groups and talk about them there, and that's why we're getting so much investment into, time investment into translations, into providing presentation material, into getting volunteers to just do these small steps to make them more known and involve more people in the discussions. And at least with integrators, we now have 2 integrators, Grantech and another one who is currently in the process of filling out these application notes, who are starting to do that. And honestly, it's a year since we published version 1. A year later, at least 2 integrators, that's not too bad. But we're still waiting for the vendors. I would be most happy to include any vendor in there.
So I got a question for you about the vendors. Since 62443 has device certification and there's a lot of PLCs in there, are you getting any resentment from them saying, why should I bother? I've got 62443. It's internationally recognized. It's a standard, not a best practice. So our vendor, because as a vendor, I remember that it was getting out of control. Everybody wanted you to have these stamps. And it's like, stamps aren't cheap for a vendor. They cost a lot of money, both to obtain and to maintain. So what are the vendors saying? Are they in but busy, or are they saying we're not going to do it because we think we already have the security document and the security accreditation that's already out there?
I would completely not bother, or I would even support, I think that's true for most of the project, if it eventually became, the points became integrated into 62443. The reason why we didn't do that in the beginning or the reason why the project was created is based on work that Jake Borski and Isaiah Jones were doing. They are very active in ISA. And they didn't do it in ISA because they kept talking in their ISA working groups, say we need to do something about PLC security, we have ideas here, and they didn't manage to get it into there, and they wanted to do something anyway. And we wanted to do something fast. didn't want to wait like 10 years until a standard comes out, and 62443 has so many consolidation issues right now anyway. If you now come there and say, well, I have an idea for 20 more requirements, it takes time to get them into there because they just have different issues right now. So what we wanted to do is get something out there fast that's not worthy of a standard yet, but provide material that can be taken and maybe integrated into a standard later on if it's more mature, and then also get it through the entire consensus-based process. So that's totally an option. We just wanted to move more quickly. That's why we started to do it in a new list. But I'm totally with you. You shouldn't create the next standard if there's already a standard covering it. But people were missing more concrete guidance for PLCs in 62443. And 4-2, for example, does include some things pertaining to PLCs. But for example, what they have in there is PLCs or devices need authentication. And again, we have that problem. Most PLCs are not capable of authentication right now. And things that we have in there are more low level. There are more smaller things. There are tips and tricks. There are probably even things that are not on ISA requirements level as IEC 62443 is written right now. They're not standard requirement level. They're smaller things, and also the things that you mentioned before. Can't we have like different procedures for different kind of PLCs? That's not something you would get into an ISA standard.
I agree, and since I'm a voting member on 62443, I completely feel the pain. The thing that I'm wondering is maybe the approach is not to try to put it in the device certification, but to put the coding stuff in the integrator certifications that would bring it into the 2 family, not the 4 family.
Yeah, so what we wanted to do, honestly, is getting the first discussion of, the first awareness of what do we think needs to be done about securing PLCs ahead of that standard discussion. So create a working document that people can take and do with whatever. Like if someone says, okay, I regard it as my job to take the top 20 and try and integrate it to wherever it fits best in IEC 62443, go for it. You will have a lot of support in there. Like there's also a lot of people in ISA who support that project, who are aware of that project, and who support it, and who would support anyone who wants to try and get that in there. So we have open doors there. But again, there's just something, one of the many side projects we have in the top 20. If there's any volunteer who says, well, that's my thing, I have a passion for that one, and I want to dedicate my free time the next 2 years to do that, you have so much support.
Great. So looking at a question here from the Slido, and this circles back to something that Joel mentioned as well. In the recommendations, it talks about using multi-factor authentication, and it's interesting if you look at many of the advisories from vendors of PLCs when they have a vulnerability, it'll also talk about using multi-factor authentication as a compensating control. A lot of these things don't even have authentication turned on. How do we reconcile these two things?
Well, I mean, this third-party data interface, I think, is kind of an extreme example here where you're allowing a third party directly to a level 1 device. So you are potentially having more risk there. I'm not exactly sure. I didn't write this one, but I have seen people solve this with gateway-type products where, at a substation or at a field site where you have that authentication capability, a number of vendors sell those, and then once you authenticate to that gateway, then you're in there. But that is, to actually have that on a PLC, that's very aspirational.
Yeah.
I mean, if they don't have authentication, asking for multi-factor authentication is, but I don't know that exact text for that requirement.
What you also see in there is the community project vibe. As we said, we don't have any spokespersons for the top 20 project, neither am I. So if I'm stating that's not technically feasible and someone wrote in this practice that they want that, well, there's two opinions, right? And also maybe that's just different experiences, because maybe it's not feasible for one PLC manufacturer, but it's totally feasible for the others. I'm not claiming I know what's technically feasible for all the PLC manufacturers. So maybe that's an important bottom line for all the top 20. Take them with a grain of salt, really. Take them and take them as a conversation starter on what you should be thinking about if you want to think about secure PLCs. If secure PLCs are not relevant to you, put them to the side. I agree there can be more important topics. If secure PLCs are relevant to you, even for a small portion of your PLCs, well, there's a conversation starter on what you could start thinking about. And anything that's not technically feasible for your PLCs, put aside, don't do it. But consider these things. Start getting into conversation with your integrators and vendors about these things. I mean, maybe they are feasible, and you just don't know because you've never used that feature, because that is also something that we really see often as like a hen and egg problem, right? The asset owners say, well, integrators, vendors, could you tell us what security features you have? And how we integrate them and how we use them. And the integrators and vendors say, well, asset owners, could you please tell us what security features you require? So we see there, and we have got a deadlock, right, of people who are saying, I don't know what you require, so I don't know what to integrate into my components. And the other side says, well, I don't know what to integrate into my components because I don't know what you have. And that's why we started the Top 20 project, to at least start the conversation on what could be wanted from both sides, right?
I have a slightly different take on this question. So if we are talking about a gateway device, and we're trying to authenticate to the gateway device, I think there is some value in saying that we want to have authentication so that we are allowed to pass through, and that communication is allowed to, the communication between the PLC to the HMI is allowed to happen. Right, but if we are talking about authenticating to the PLC itself, I think the question is, so why are we authenticating to a PLC? Is it to perform some control in there, or are we trying to say that the communications, we need to authenticate so that we can then authorize the communications to then happen? So many of the PLCs that I see actually have always on communication, so there's no real like expiry or token expiry. And so I have a little bit of question about, well, when we are trying to do authentication, what is the purpose behind the authentication? What are we trying to authorize? What are we trying to allow? And whether that fits into the OT environment as well. Because some things don't naturally, I mean, there are some kind of communications that we don't expect to expire in an OT environment.
No, I think that's a really good point, because I think for a long time people have confused the intent of authentication. I agree. We don't need authentication. We need management of authorization. Because
yes, exactly.
there is got to be authorization once you're authenticated, and then typically you would need accounting and logging. And that's why I go, everybody's on an authentication kick because we're used to logging into computers. I think what you're allowed to do is more important than who's allowed to do it. I guess it's all about risk, right? So authentication could be compromised. And if there's no authorization restricting what you could do, you're kind of in a pickle there. But if you had authorization control, then it doesn't really matter because you've locked the machine down and limited the ability of what can be done with it.
How do you implement authorization if you don't have authentication?
You don't need authentication. We've been doing it for decades. DCSs, it's the cornerstone. We do not do authentication on DCSs. We do authorization.
How do you limit what someone can do if you know who someone is?
Because everything's based on roles. Everything's based on roles. So you create areas of responsibility.
Role-based
and
authentication is authentication, right?
We don't do it with authentication. We do it with, for instance, hard-coded. So a workstation is allocated to a specific area of responsibility, and that specific area of responsibility is in the core configuration of the control logic, so that those people can only do specific functions that are in that area of responsibility.
I agree, but then you have to identify what role is acting there.
But that's how we've been doing it.
Authentication of that role.
No, it's not. There's no authentication. There's no user password scenario. It's purely user. So there's no second part of that. It's just user. It's an identification with an authorization against it. Like operator one.
I agree, you can look at it that way, but I think we're getting to philosophy there. So You have to, I mean, I think we get what we're saying, right? You have to restrict what people are able to do at a PLC, and you have to restrict who or which role is able to do that.
Who says, right? It's more important to control what's done than it is who's doing it.
Well, I think you do have to have some knowledge of who or what machine is doing it. Oftentimes, if you look at these products, sometimes it's the GUI, so you've logged into the GUI and the control is done on the client side as opposed to on the controller side. But I mean, we can get into, we can get pretty deep on that. I think if you want some encouraging news, if you look at Modbus Secure, now a lot of people don't like TLS, they don't like the Rapid in TLS. We've had whole debates on that on the S4 stage. It's probably not the right solution, but Modbus TLS, or Modbus Secure, SIP Secure for your Rockwell folks are all Rapid in TLS, but one of the things they're doing is they are adding authorization. So the certificates that are exchanged also can include roles. So not only would you get the authentication of the person, but you'd also say, here's the person, and by the way, they are allowed to do operator things, or they are allowed to do engineer or technician things. So we are seeing a little bit of forward progress from the vendors, and we probably should applaud them for that. You know, that is progress. We've been waiting a long time.
Yeah, but I'm gonna take this back because no, we don't. We had keys before. And if I'm the only one with a key, I could put it in there and I'm the only one that can do the changes. The vendors pulled keys a long time ago. Why? So to obtain what you want, all we have to do is get the vendors to give us back the key. Well, half of them have the key. So half of them have met the authentication requirement. Why do they have to have multi-factor authentication when you have a key? So again, the fact that they leave a key in all the time, it shouldn't be the argument because they're doing authentication. That is technically authentication. But so everybody seems we have to rewrite code now to provide a functionality we've had. And some vendors still do it. But there's other vendors that for some reason have chose not to. So how are we ever going to convince those vendors to come back?
Well, the key switch is actually a great example. I think we actually have that at some point in the top 20 because it's also something that was, as you said, is really different between different operators. Some really require that for all of their PLCs, and I've been in those conversations at operators who really force, I think it was Siemens, into reinserting the key switch. No, not a software key switch, which is in the end is a password, but a hardware key switch back into their PLCs, at least for the safety relevant ones. But I think that is a prime example why the top 20 are needed. Because that is something where we say, look, if you're talking about a secure PLC, we removed the key switch for other reasons. They were never inserted for security reasons. But they're also security relevant, so we want them back now maybe for a different reason. If you do agree on that, we want them back. So that's a prime example for security decisions. As I said earlier, you're making security decisions all the time. The question is if you're aware of that. And the key switch is a really good example because keeping the key switch at a time, maybe 20 years ago, wasn't a security decision, but you had it anyway. And now we said, okay, anyway, that wasn't that bad, that key switch. It was a good thing, and for security reasons, we want it back. And another good example is reinserting humans into the loop. We removed them for different purposes because it's more efficient, because it's more economic. And now we say, okay, actually, we realize removing humans or maybe cutting down on operators is also a security decision. Let's make it conscious that that is a security decision, and it makes sense to reinsert that human into the loop. And this is the idea and the philosophy that's behind the top 20. Not integrating new fancy security features, but thinking about what the current PLCs can do that can also help security. So that's why I think the key switch is actually a very good example for that one.
So one thing I missed, I didn't see it, and if I missed it, tell me. Why doesn't the standard address the basic concept of separating configuration communication channels from data access communication channels? I was shocked to not see that there. To me, that is the single biggest reason I don't like Siemens. all comms exists on TCP 102. So you have no way at a different area, right? I like layers of protection. So the device is one, the network's the second. You can't do that because, see, they do everything across 102, where other vendors split engineering functions from operational functions. How come that didn't make it in?
I'm not sure if I'm the right person to answer the question since I'm not the vendor making that decisions, right?
No, but it's your coding practices. You guys you're the ones that oversaw what you determined to be the top 20. You argued that authentication is such a big deal. I much more prefer, I don't care who reads the data. I care about who can change the logic. So to me, if I had to pick a function, I would rather pick the separation of communication and data comms than I would put authentication in the PLC. And I bet the vendors would probably go, well, shoot, Rockwell would say, done.
Sounds like a great thing for version 2 of the specs. So we're at time. I want to thank our panelists for a great, lively discussion. Very much appreciate it. Thank you.